This one, test one, test one. Right. Okay. Okay. Then today we are going to briefly remind about units and dimensions. Actually, today we are going to discuss about basic units, right? Basic units. Buddha, why do we need units? Why do we require units? For what? Why we need units? Ah, sorry, to measure something, no? Right. Okay. Then, as an example, yes, if your mother asks you to bring five, right, rice. Can you imagine what is this? No, it's very difficult. Yes, if she asks to bring 5 kilogram of vegetable, this is very well clear, no? Okay. Then sometimes if you want to measure distance between distance between Sri Lanka to sun, can we use millimeters for this? No. Then what we have to use? We have to use another unit, no? Okay. Then if you want to measure diameter, sorry, length of bacteria, can we use meters or can we use kilometers? No, it's very funny, Right, then we need to use, right, suitable units for the units to take required measurement, no? Right. Then in the world, there are 7 basic units, right? In our world, there are 7 basic units, right? Okay. Now you can see in your board, first one is length. To measure length, we can use meter as basic unit. To measure length, we can use meters. Then second one, mass. To measure mass, we can use kilogram. No. Then time. To measure time, basic unit is second. Right. Then thermodynamic temperature. In our day-to-day life, we are using Celsius. But in science, to measure thermodynamic temperature, we have to use Kelvin scale. It's not Kelvin degree, it's just Kelvin. Celsius degrees means we have to put a small zero mark, no? But in here, Kelvin, you have to just apply Kelvin. Right. Next one, electric current. We have to use ampere. Huda, ampere and Kelvin are names of the persons who were introduced these units. Therefore, we have to use block capital letters to not these Kelvin and ampere, right? Kelvin and ampere, right? Then amount of substance. Assume, uh, okay, you want to make a cup of tea. You can put one sugar and you can make your tea, right? Or then you can add another 2 or 3 spoons of sugar. Then what will happen? Yes, your taste will increase. That means amount of substance, right? Or otherwise, the portion of sugar has increased. We call that as amount of substance. We have to use small, right, to measure amount of substance. And then, okay, sometimes your mother is asked, Uta, switch on the light. Or otherwise, they are asking, yes, why you are switch on this light? Yes, now, yes, sometimes. In our homes, yes, mother sometimes ask you to switch on the light and switch off the light. Why? Yes, luminance intensity, right? Okay, that means yes, level of the light we have to use to measure candela, candela. Why they haven't used Ca to candela? Because Ca is we are using to represent calcium, no? Therefore, we have to use Cd, candela. Okay, these are the main seven basic quantities and corresponding SI units, right? What's the meaning of the SI units? Actually, it's representing international standard. But I think there's a organization called ISIS, no? Right? There are a lot of IS in the world. Therefore, they haven't used IS and they have changed the letters and they have introduced SI, international standard, right? Okay. Then we have length, mass, time, thermodynamic temperature, then electric current, amount of substance, and luminance intensity. Okay. close your book and have a try to fill the blanks. Right. Okay. No, I think for you, right, you can fill the remaining blanks. Close your book and don't you have a rough sheet? I know my rough sheet again. Ah, okay, okay. You can use them. Okay. It doesn't matter. අපි අනිවාර්යයෙන්ම මේවා capital letters ද simple letters ද කියන එක more important. ඒක අපි බලන්න ඕනේ මොකද්ද වෙන්නේ කියන එක. ඒ කියන්නේ මේකේ capital letters ද simple letters ද යන්නේ ඒක පොඩ්ඩක් බලන්න ඕනේ ඈ. Okay. Right. Check. Right. මේ ටික check කරන්න බලන්න පුතේ. Right now. Okay. Then we can go ahead. Right. Okay, Pata. Now we have, in addition to the basic exercise units, we have remaining two supplementary exercise units. But we do have two supplementary SI units, right? Why we are taking supplements? Yes, as in foods. Normally we are taking main meals, no? In addition to that, we are getting some supplements, no? Why? Main food is not enough to live, no? Therefore, we are getting some supplements, no? Okay, likewise, in the units, in addition to main units, we need to have another two units to explain the physical scenarios in this world. Right? අපිට මේ ලෝකයේ තියෙන physical දේවල් explain කරන්න පුතාලා දෙකක් ඕනේ. Right? First one is plane angle. Plane angle means the angle what you are measuring using the compass. But in compass we used degrees, but in the beginning we learned in A levels we are using radians. Yes. To measure plane angle or 2D angle, we can use radian. And if we want to measure 3D angle, assume beam of this projector, can we use 2D angle to measure this beam? No. Right, to measure 3D angles or solid angles, we need to use steradian. Steradian, right? Steradian. Steradian. Plane angle we need to use radian, and a solid angle we need to use steradian. These are supplementary SI units. These are not main SI units. These are supplementary SI units. Is this clear, Buddha? Okay. Hari, මේක තැන ගන්න. Hello. We can go to next. Right. Okay. Uda, in O level, we learned area. Right. Okay. In O levels, we learned area. Right. Okay. Area. Right. L into B, no? Or whatever. I don't know. Right. Then, if you want volume, calculate volume, area into, yes, length of anything, right? Right. Any dimensions you can use, right? It doesn't matter. Right. Then, if we want to measure area, we can measure one side using meters and other side also using meters. Then what is the units of area? Area is units of the area. You can write m squared. No? Units of the area you can write m squared. No? Okay. Then unit of the volume. Meters, meters, and meters. You can write volume. Units of the volume as m cube. No? Unit of the volume you can write as m cube. Is it clear, Buddha? Okay. Right. Then, when it comes to velocity, what is the definition of the velocity or equation of the velocity? Displacement over? Yes. Velocity you can write displacement over time, no? Displacement we can measure using meters. Displacement we can use meters and time second. Then when you take s into the upwards, you can write ms minus 1. Meters per second. Meters per second. Right? Then acceleration. Acceleration. Yes. Velocity over time, no? Velocity you can write ms minus 1 time per second, then ms minus 2. Meters per square second, no? Meters per square second, no? Meters per square second. Right? Okay, no? Right. Then, if you want to calculate force, we know F is equal ma, no? Mass into the acceleration. Units of mass is kilogram and acceleration is ms minus 2. Kg ms minus 2. Is it clear? Okay. Right. Then density. Density. You can write mass over volume, no? Density is equal mass over volume. Mass you can write kilogram and volume m cube, no? Then kg, m, kilogram per cubic meters. Kilogram per cubic meters. Density. And momentum. What is momentum? Right. Assume like this. Right. If you are hitting this wall with velocity of 10 ms minus 1 using a small ball, and you are attacking right, any other vehicle with the same velocity. අපිට මෙන්න බෝල් එකකින් පුතා මෙන්න 10 ms minus 1 වෙන්න ගහනවා. තව එකක් මම ටිපර් එකක් ගලලා මේක 10 ms minus වලින් හිට් කරනවා. මොකද පුතේ වෙන්නම ඉම්පැක්ට් එක දෙන්නේ? ටිපර් එකනේ. Okay. Then assume you have a bullet. Right? Bullet and ball. Then when you are hitting ball and bullet, I think bullet has more velocity comparing with the ball. Then which one is making higher impact? Bullet, no? That means sometimes the higher impact is depending on the mass, and sometimes depending on the velocity. Okay, then momentum we can write mass into the velocity. You can write mass into the velocity. Mass into the velocity. Mass you can write kilogram, velocity ms minus 1. Momentum. Is this clear, Buddha? Okay. Then I think you learned a lot of these things in your O levels. Okay. Right. Make a ලියන ගමන් පාඩම් කරගන්න. ලියන ගමන් පාඩම් කරගන්න. Right. and pressure. Right. Okay. Force. We can write F is equal m into a, no? Mass into the acceleration. Mass we can write in kilogram, and acceleration we can write m is minus 2. If you are writing units of the force using fundamental unit, so basic unit, you have to write this kgm is minus 2, right? Then pressure you can write force over area, no? Force over area. Then force you can write kg, yes, m is minus 2, and x, sorry, area m squared, no? When you take m squared to upside, you can write kg m minus 2 kg m minus 1 clear the right? Okay, right? Okay, then wait, but in normally we are not writing this unit for the force, no? Simply we are using Newton. Simply we are using Newton, right? This is the specific name, right? Instead of kgms minus 1, we can directly write Newton. It's the specific name, no? Right. Then pressure, instead of this unit, you can write Pascal. If you are writing unit using name of the person, first letter should be capital block letter, and second letter should be simple Pascal, right? Okay. Pascal, right? Then when you go to the slide, when you go to slide, you can see, right, special name Newton and Pascal. Both are names of the person, right? First letter should be capital block letter, and if we are using second letter, because if already P used, then we have to write second letter in small letters, right? Okay, then pressure, we can write force over area, right? If you write it in fundamental units, you can write this, but force, you can write in Newton, no? Newton, no? Then you can write area in square meters. Then you can write it as Nm minus, right? This is using basic unit. This is special name, and this is using other SI units or using other units. Clear the pata? Right. Okay. Hari, lihan the bar. We'll go ahead. Right. Right. Work. Work you can write force into the displacement. Right. Force into the displacement. Right. First, right. If we use a specific name, then you can use joule. You can use joule for work and energy. Both has same unit. Work and energy has same, right. Then work, you can write force into the displacement. Force, if we use using fundamental units. Fundamental units, you can write kg ms minus 2, no? ms minus 2. Displacement, displacement is a length, no? Then you can write meters. Then you can write kg, sorry, kg m squared is to the power minus 2. Right. To energy also you can write the same. Energy also you can write the same. Then work you can write force into the displacement. Force in other units. Yes. Instead of kgms minus 2, you can write Newton, no? Newton in capital block letters, Newton. And displacement you can write meters. Newton meters, no? Right. Is this clear? Right. Ability of work also you can write same, no? Right. Then energy. I think you have learned two type of energy, potential energy and kinetic energy. You can check, yes, potential energy you can write mass, gravitational acceleration and height, no? mgh. And kinetic energy you can write half, yes, mv squared. Using these two equations also, you should need to get this answer, no? Check. Before you write this, check whether true or not. Yes, if it is true, tell me, then we can write. But before that, don't write. Huh? Okay. Maybe check run We'll see how it came. Right. If you write that energy or work, we know we in all levels we learn two type of energies. No, what are those? We learn two type of energies. What are those? Potential energy and kinetic energy. In potential energy, you can write mgh, mass, gravitational acceleration, and height. Then kinetic energy, half mv squared, no? Mass, kilogram. Gravitational acceleration also and acceleration. Gravitational acceleration also and acceleration, no? Then ms minus 2 and height is, you can consider as length, then you will get kg m squared s to the power minus 2. When you use this half mass, you can write kilogram v squared ms minus 1 into full square, no? Then you can multiply from 2 half kg m squared is to the power minus 2. Is this clear? Right, okay. Half, because this is just a number, right? This is just a number, no any impact from the half. It's just a number. It's not a power. If it is power, you have to consider about this half. But this is just a number. Numbers generally don't have any units. Therefore, you can escape or you can forget half. Clear, Bude? Right, okay. Then we'll go next. Okay. मैं clear आपसे कहा क्या? Right. Okay. Wait, I will. Okay. मीके न्यूटन यूज करला, जूल यूज करला, फंडामेंटल यूज करला, डिराइव करला. Right, we'll see. Power in what? Right? Power in what? You can write work over time.
right? You can write work as force into displacement over time. Then force you can write mass into the acceleration into displacement over time. Work you can write joule, time in second. You can write J is minus 1. This is the first one. Then force in Newton, displacement in meter and seconds. Then you can write in per second. Mass, kilogram, M is minus 2 meters in seconds. Kg, M squared minus 3. This is in fundamentals, no? These are in other units. Other, and this is fundamental. But power has another specific name. Do you know James Watt?
James what? Another James what? Huh? Yes. Represent him, we can use what? What? Make clear the Buddha? Right, okay. Then, next one. Frequency resistance, hertz. Frequency resistance, hertz. Number of vibrations over time. Number of vibrations. Means it's just a number, no? Number of vibration means just a number, no? Okay. Just I can write 1 and time second. Then units of the number of vibration is per second. We have specific name hertz. HZ. Hertz. Name of the person. Hertz. Okay. But in your resource book also, they haven't mentioned these all units. Then weight J is minus 1 and Newton meters per second. And MS1. Okay. ප්‍රොසීජර් එක. දැන් ඔයා ඊට පස්සේ බලන්න ඕනේ කොහොමද මේ ටික තනියම කරන්න කියලා. ක්ලියර්ද? රයිට්. එතකොට මේ බලලා ඔක දෙපාරක් විතර කියවන්න. දැන් මම දැක්කද කේස් එක කරන විදිහ? දැන් ඔතනින් ගහට ඉස්සරහ පොඩක් self studies පාරක් දාන්න. ඊට පස්සේ අපි මේකේ questions පට්ට අමාරුයි. right okay එහෙනම් see you on next week. අපි දිගට පුතේ Friday ගමු.